Hello friends, the topic for today is Arduino Nano Pinout. Arduino Nano is a small, complete and breadboard friendly board based on the Atmega 328P microcontroller. Arduino is on a mission to make technology accessible to everyone and into the hands of every student and educator. To make this possible, they have created Aurdino Education, a dedicated global team formed by education experts, content designers, engineers, and interaction designers. Arduino is an open source electronics platform based on easy to use hardware and software. You can tell your board what to do by sending a set of instructions to the microcontroller on the board. To do so, you use the Arduino programming language based on wiring and the Arduino software, that is IDE, based on processing. In today's video, we'll discuss about the technical specification, the pin layout, and the functions of each and every pin of the Arduino Nano board. Let us start. Welcome to our channel Engineering and Technology for You. Arduino Nano Pinout, that is the topic for today. Let us start with the introduction. Arduino introduction. Arduino is an open source electronics platform based on easy to use hardware and software. Arduino boards are able to read inputs, light on a sensor, a finger on a button or a Twitter message, and turn it into an output, activating a motor, turning on LEDs, publishing something online. So you can connect with the outside world with the help of this board. You can tell your board what to do by sending a set of instructions to the microcontroller on the board. To do so, you use the Arduino programming language based on wiring and the Arduino software IDE based on processing. These are available on the website. I have put it in the description. Then Arduino Nano introduction. Now, Arduino Nano is a small, complete and breadboard friendly board based on Atmega 328P, that is Arduino Nano 3.X. It has more or less same functionality of the Arduino diploma, but in a different package. The Nano board weighs around 7 grams and dimensions of 4.5 centimeters to 1.8 centimeters left to bottom. It lacks only the DC power jack and works with a mini B USB cable instead of a standard one. So it is very compact. Then let us start with the technical specification. Microcontroller Atmega 328, then architecture, that is Advanced RISC Architecture, AVR. Then operating voltage 5 volts, flash memory 32 KB, of which 2 KB used by the bootloader for the initial program. Then SRAM is 2 KB, then clock speed is 16 MHz, analog in pins, there are 8 analog in pins, then EEPROM is 1 KB, then DC current per IO pins 40 milliamps per IO. Then input voltage 7 to 12 volts, then digital IO pins 22, 6 of which are PWM. So out of this 6 are PWM. Then PWM output 6, then power consumption is 19 milliamps, then PCB size is 18 by 45 mm and weight is 7 grams. So it is very compact board and it is breadboard friendly. So you can test your circuits on the breadboard. So this is the Arduino Nano Pinout. You can see here it has got digital inputs D0 then D1. These are the two inputs. Then from D2 to D12, these are the inputs from D2 to D12. These are the digital pins. They are designated from D0 to D12, and then there is one more pin D13 here, pin number 16. So the pins are designated from say 1 to 15, then 16 to 30. So it's 30 pin IC, the board. Then we have the ground pin RST reset, that is reset, and RXD, that is the receiver pin. Then this is the transmitter TXD, transmitter data. And on this we have, on this side we have the 8 analog input pins A0 to A7. So these are the A0 to A7, these are the analog input pins. Then this side we have the plus 5 volt RST, again reset, then ground and VE. So that is the input voltage. Then this is 3.3 volt output from here, and this is the analog reference ARF. Then this is the digital pin 13 we have already discussed, and then this is the mini B USB jack. So here you have to put that for the connections. Then this is the SMD crystal 16 megahertz, and this is the microcontroller ADMEGA 328P. So this is how the pinout of Arduino Nano is there. Let us discuss the different pins here. First, the digital pins description. Now D0 to D30, these are the 14 digital pins on the Nano, and can be used as input or output using the pin mode, digital write and digital read functions. So these are the functions which are available for the different modes of the pins, then read and write. Then they operate at 5 volts. Each pin can provide or receive a maximum of 40 milliamps and has an internal pull-up resistor of 20 to 50 kilo ohms. So that is provided there. Then in addition, some pins have specialized function. So here we'll discuss the specialized function now. Serial communication pins. So pin 1, that is RX and TX, pin 2 TX, these two pins, RX is for receive and TX is for transmit, are used for TTL serial data communication. The pins RX and TX are connected to the corresponding pins of the USB to TTL serial chip. So with this you can do the serial communication. Then next we have the PWM pins. Each of these digital pins provide pulse width modulation signals of 8-bit resolution. The PWM signal can be generated using the analog write function. So these are the functions which are available in the library, and we can use this for the connecting the PWM signal. So with this we can control the motors if you are going to connect the motors with the board. Then next is external interrupts. These pins can be configured to trigger an interrupt on a low value, a rising or falling edge, or a change in value. So all level trigger, then edge trigger is possible. Then here attach interrupt function, you can just go through this function for the details. Then the serial peripheral interrupt, SPI. So here we have 4 pins, SS, MOSI, MISO and SCK. So these pins When you don't want the data to be transmitted asynchronously, you can use the serial peripheral interface for the synchronous transmission. This means supports synchronous communication with this synchronizing clock. SCK is the synchronizing clock. We'll see the details of this serial peripheral interface on the next slide. Now, even though the hardware has this feature, the Arduino software doesn't have this by default. So you have to include the library called SPI library for using this feature. So this has to be included when you are using this feature. Then the next pin is LED D30, that is the digital pin 30. There is a built-in LED connected to digital pin 30. When the pin is high value, the LED is on. When pin is low, it is off. So it is for the indication. Then analog pins. The Nano has 8 analog inputs, each of which provides 10 bits resolution. So there is the resolution is 10 bits. So 2 raised to 10 is 1024 different values. Then by default, they measure from ground to 5 volts, though it is possible to change the upper end of their range using the analog reference function. So with the help of this function, you can change the upper range of this. Then analog pins 6 and 7 cannot be used as digital pins. Additionally, some pins have specialized functionality. Here this analog pins have some additional functionality. First is I2C or I2C. Now, since SPI communication also has a disadvantage that it needs 4 pins and is limited within the device, we can go for this. For long distance communication, we use the I2C protocol. So I2C supports multi-master and multi-slave with 2 wires, that is one for clock SCL and another for data SDA. So these are the 2 wires which are used in the I2C protocol. For using this I2C feature, we need to import the library called wire library. So with the help of this wire library, we can use this I2C feature of this board. Then other pins, they are A reference, that is analog reference pin, used as a reference voltage for the input for the ADC conversion. Then reset pin, pin number 28, bring this line low to reset the microcontroller. Typically used to add a reset button to shield which blocks one of the on the board. So that is, we can reset the microcontroller with the help of this pin. Then let us go to the part that is Arduino Nano ISCP, that is in-circuit serial programming. ISCP stands for in-circuit serial programming, which represents one of the several methods available for programming Arduino boards. Ordinarily, Arduino bootloader program is used to program an Arduino board, but the bootloader is missing or damaged ICSP that can be used. Then ICSP can be used to restore missing or damaged bootloader. Each ICSP pin usually is cross-connected to another Arduino pin with the same name or function. So here MISO on Nano's ICSP header is connected to MISO, that is digital pin 12. So here this MISO pin will be internally connected to digital pin 12. Then MOSI, that is connected to the MOSI pin on digital pin 11 or pin number 16 and so forth. So note that these pins are taken together, make up the most of the SPI interface. We can use one Arduino program, another Arduino using this ICS. Now let us see the ICS pin details with the help of this serial peripheral interface. Now in the serial peripheral interface, only one side generates the clock, that is usually the SCK or serial clock. Then the side that generates the clock is called master and the other side is called as the slave. So there will be one master, another slave. So the master will generate the clock SCK. There is always only one master, which is almost always your microcontroller, but there can be multiple slaves. More on this in a bit. So that is, we can use the microcontroller as the master and there can be multiple slaves. Then when data is sent from master to a slave, it sits on the data line called MOSI. Master out, slave in, MOSI. That is the meaning. So data will be sent from MOSI, from master to the slave. In the slave needs to send the response back to the master will continue to generate the pre-arranged number of clock cycles and the slave will put the data into the third data line called MISO. That is master in, slave out. So here master in, slave out. On this line, the slave will put the data on this line. Master in, slave out. So these three signals are used for the serial peripheral interface. SCK, that is the clock. So you can see this is the clock. And then master out, slave in. Now here if you the character say yes is to be sent, that is hexadecimal, it is 53. So accordingly it will take the values. Say 0 1 0 1, that is 5, and 0 0 1 1, 53. So 5 and 3. Then similarly master in, slave out. If the slave wants to send, then here ASCII value F, the hexadecimal value for that is 46. So 0 1 0 0 and then 0 1 1 0, that is 6, 4 and 6. So in this way this will work. So this was in short the serial peripheral interface. Then let us go to the programming part. The Arduino Nano can be programmed with the Arduino software. Select Arduino Nano or Nano at Mega 328 from the tools. Now board menu according to the microcontroller on your board. So whatever microcontroller is there on the board, as per that we'll have to do. The ATmega 328 on Arduino Nano comes pre-burned with a bootloader that allows you to upload new code to it without the use of external hardware programmer. So without the external hardware programmer, you can load the code, new code into this board. Then it communicates using the original STK500 protocol. You can also bypass the bootloader and program the microcontroller to ICSP, that is in-circuit serial programming header using the Arduino ISP or similar. So this we already discussed, ICSP. So then applications. Mainly this board is used for prototyping of electronic products and systems. Then multiple do-it-yourself projects. Then easy to use for beginner level do-it-yourself, those who are beginners or these do-it-yourself and makers. Then project requiring multiple I/O interfaces and communication. So these are the general applications. So if you take specific example, we have the Arduino metal detector, then obstacle avoiding robot using Arduino and ultrasonic sensor, then Arduino wattmeter, that is measure voltage, current and power consumption, etc. So with the references for this, so this is the website Aurdino.cc. So you can visit the website and get the details of this, and this material is released under the Creative Commons Attribution Share Alike 3.0 licenses. So I mentioned it here it is a open source and you can always use the material and share it with your friends. So with this we come to the end of this video. If you like the video, please press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And if you want to get notified for more videos on Arduino and the Atmega 328 microcontroller, subscribe to our channel and then press the bell icon. Then for any queries you can contact me on my Facebook, Twitter and the email account or Instagram. Thanks for watching. Have a nice day.